Hi there, I'm Nena Dilic, a Senior Developer Advocate for AWS IoT. And in this video, I will be going over a setup for debugging C or C++ AWS IoT Greengrass components using VSCode. In most scenarios, simply logging the output of the application is enough to understand what is happening and perform debugging in case there is an application misbehavior. However, sometimes in order to catch some stubborn bugs, stepping through the code while application is executing might be the most effective way to do it. So Greengrass provides a CLI tool that allows local components to be deployed and tested by also accessing the application logs. But in scenarios where we want to step through the code and understand the stack and other parts of the memory of a C or C++ component, then we would need some additional configuration, which we will demonstrate right now. So here I have an EC2 machine running a plain Ubuntu 2022.04, and I'm using VS Code remote development using SSH to access it. So I can just demonstrate here, we have that. And then I will be going through a Greengrass installation steps provided in getting started, which is more or less downloading the Greengrass installer and then running it with some configuration here. And you can see these are pretty basic configuration. We'll have the Greengrass Quick Start core, and we will also provide this deploy dev tools, which allows us to install the Greengrass CLI, which we will need later. After this is done, I should be able to verify that the Greengrass is installed and running. So yes, we can see it here, that's basically done. Now, before we can build our C++ application, we need to make sure that we have the AWS IoT Device SDK for C++ version 2 built and available to link against, as it provides the Greengrass IPC library, which we'll need to communicate with Greengrass. So I will follow the steps from the blog. I'll just create a workspace here quickly and then clone the repository. So once this is cloned, I'll just want to make sure that we have all the Git submodules as well. I think they're already in here because we put the recursive, but let's just double check. So just to make sure that we have everything in place, and yes. And we will create a new directory, which is this AWS IoT Device SDK CPP version 2 build, which will be the directory we'll be building our SDK. So let's just make sure that the path is correct. So here, double check. So we have the home Ubuntu. Here I have blog, then SDK. I think here, wait, here, CPP, and then that should be it. So once this is done, I should be able to now build the SDK, and that will take a while. Okay, now that we have the SDK almost built, now it's there, we can proceed and create our folders for the Hello World application. So let's just get out of here, create a folder, it's called Hello World. So just get into it, and then in here, so here we want to create a new file, which is the cmakeLists.txt, and then we need to populate it with something like this, which it's just which is minimum required version, hello world, getting everything from the source. And then here we need to make sure that the path is correct. So here we need to modify this to be a blog. So let's put this here as well, and that should be fine. So now that we have the CMake list, we want to create a new file, which is the main.cpp, which will have the application. So again, this is the application that you will find the code for this on the blog post that will be linked and referenced here. So paste this here. More or less the application is defining the topic and subscribing to that topic, more or less here, and then creating a stream handler for the response. So this here will be catching the messages that are coming from the IoT core, and more or less we will be just printing them. That's what this is a hello world example. So the next part would be to create a directory and then cd into it. And here it's important that we specify the right location where we have our SDK build directory. Yeah, so make sure that everything is fine, and then more or less perform the build. We have now a hello world application, but it will not run on its own because it requires Greengrass and the IPC. So what we need to do is create Greengrass recipe and copy the artifact. So let's just run through those commands. So I will just create this here, but we can see it here. So basically this is the recipe, and I will just copy paste the example that is provided in the blog post. So what this is, it's creating a component that is the C++ component that has capability to subscribe to the AWS IoT core on this specific topic, and it will just run the hello world. So as of now, this will be just running our component. So let me also copy the build to the artifact directory, and after this we should be able to deploy this. Okay, and now let's deploy the component using the Greengrass CLI. And so we see that this is deployed, and let's take a look at the logs, and we can see that the deployment worked and we have successfully subscribed to the topic. So this is great, but now what happens if there was a misbehavior within the application? So, and we want to debug, like once the message is received from the AWS IoT core to Greengrass, how this is handled, and we want to investigate the stack and all the memory and the variables there as well. So for those situations, we will proceed now with creating the launch.json, which we will be using the GDB server to do this debugging. So the first part is to create a folder, VSCode, and then inside create a file, launch.json. So in there, this is the configuration we have in the blog post. We can put this, which more or less we will be using for debugging purposes, but it will attach to the GDB server, and then it will allow us to visually debug the application. The expected behavior is that this binary is located in the artifact folder, so here, That's where we will be having it, and then yeah, we can then go into debugging. In order to enable Greengrass component, we will need to modify the recipe file in such a way that we prefix it so it first starts our application using the GDB server. So this is what we need to change, and save, of course, save this one as well. And then after that is done, we need to redeploy. So to make sure that this is reflected. And then once that is done, we need to make sure that in the logs we see, once that is updated, we see that the GDB server is running. Yes, so we see here that this now application is listening to this port, and now we can go into the debugging mode. So we can just simply go open our main CPP and put some breakpoints. So I would like to put a breakpoint here just to verify that the right topic is passed, and then I would like to put a breakpoint here perhaps, and here, so that I can inspect once the data is received. So we go here, you just press a button, and that should connect to the GDB. And yes, we can see it nicely here. We can see all the variables. We can see what they are. So maybe even go through stepping. And so we can see the timeout is 10. This is the value of the QoS. Excellent. But now we have this application running. So now let us try and send some message from the AWS IoT core. So let's grab the topic we need to send this to. So this is this test. Go to the MQTT client, which is here, and then basically paste the topic here, so, and do publish. So we can immediately see that our breakpoint got triggered. We can see the message. So I can even look at the terminal and what's happening. We see that this is subscribed to topic. So since we were debugging and went through, and it's there now. And now we can more or less inspect the payload. So we can even see what the message topic is and all that stuff. And we can see that the message string here is message hello from the AWS IoT console. This was the one that we sent. If we go back, we can see that that's the one we sent. And now if I let this application run further, I can come here and then see that that message got received and processed, and it's now in our log. And more or less that concludes what I had in mind to show you. So more or less you can use the GDB server and GDB and Visual Studio Code to visualize and inspect what is happening in our Greengrass version 2 component. So we can go further and even debug multiple components at the same time, where the only thing we need to change is the port. So if I go more or less here, I can just change the port for another component, and I can also have multiple configurations, which all they need to reflect is that port. That will be all. If you find this interesting or have suggestions for future topics, feel free to reach out here in the comments or at nanadilic84 on Twitter. Thank you and bye.